This is the notes on introductions to exponential functions. So the first thing I want you to do is to complete your warm-up on Edulastic. And once you do that, come back to this screen. All right, the first thing we're going to do is review. So I want you to solve these review questions first and solve them in your notebooks. So you're going to find the distance between 2 points. Then you're going to find the midpoint of the line segment joining the 2 points. If you don't remember how to find the distance, reference your notebook and use the distance formula and midpoint formula to answer this question. Make sure you're recording down your answers in your notebook. You're going to do the same type of problem using these 2 different points here, -4, 3, and 2, 5. Make sure you simplify. When you're simplifying, make sure that inside the radical you are simplifying the number under the radical if possible first. If you have pairs of numbers, because it's square root, you can move them to the front of the radical symbol and then multiply together what you have. Once again, simplify using a prime factor tree to see if you can move any of the amount out from underneath the radical symbol to the front of it. Okay, to find the perimeter of this shape below, we know this side length here easily, and we know this side length here easily. But this side here, I can't just count the number of boxes. So what I want you to use is the Pythagorean theorem or the distance formula. Pythagorean theorem, you would use this side length here and this side length here, and using those as your a squared and b squared, and they would tell you what the c squared is, and that would be your length of this side here. And then for this side length here, you can do the same thing with Pythagorean theorem by using this as a squared, this is b squared, and that will give you your c squared. All right, so with exponential functions, make sure you have the notes sheet in front of you to complete today's notes. Exponential functions, they're equations that have the variable in the exponent. Exponential equations are found in science, finance, sports, and many other areas of daily living. Some equations are complicated, but some are not. Now, the general form of an exponential equation is in the form of y equals a times b to the x power, and that's where our exponent is. A represents your initial value, which is the starting value. B is the base, which is basically going to be the amount or the rate at which something is changing by, and x is going to be the exponent that represents the number of times something is changing. And the final output value will be y. Since the equation has an exponent, the value is going to increase or decrease rapidly. If the base number is greater than 1, the exponential equation represents exponential growth. If the base is between 0 and 1, exclusive, that is that b is between 0 and 1, then the exponential equation represents exponential decay. Now, if you're told that something is represented by a certain percent, you need to be careful with those, because 2% is represented as the decimal 0.02. But that's less than 1, and if I plug that into the equation, it's not going to show growth. So the number 1 means that something would stay the same, so it would be like 1 plus 2% more. So that gives us the growth rate of 1.02, which represents 102%. Now, if a population is decreasing, we're going to do the opposite, and we're going to start with 1, and we're going to take away the amount that it's decreasing by. So if something's decreasing by 3%, then 97% of the factor is still there that we're going to multiply over and over again. These are 2 different representations of graphs. The graph on the right-hand side, we have seen this type of graph all year. This is a linear function. Okay, what we're going to start talking about in this unit is exponential functions. So anytime we see a graph that is curving, it's going to represent an exponential function. The first example I want you to look at is on page 16 of your workbook. A population of mice quadruples every 6 months. if a mouse nest started out with 2 mice, how many mice would there be after 2 years? And write an equation and then use it to solve the problem. So first we need to reread the problem, identifying the known quantities. So some known quantities is that the growth rate quadruples, the time is 6 months, and the initial value is that there are 2 mice. So I know my growth rate, and it's not letting me write there. Let me see if it'll let me type. So I know my growth rate quadruples. My time is 6 months, and my initial values is that there are 2 mice. Okay. Now, the second question says, read the statement again, identifying the unknown quantity or variable. So my question is asking, how many mice would there be after 2 years? Now, an expression that I can use is my formula here, y equals a times b to the x power, where y represents our answer. The a is representing my initial value. My b is going to represent how it's changing with my base, and then the exponent is going to represent how many times it has changed. So my equation is going to become y equals, my initial value was 2 mice, times, it was quadrupling, so I'm going to use the number 4 to represent that it is changing by 4 times. And then they told me the growth for every 6 months. And I want to know how many mice there will be after 2 years. So there are 4 groups of 6 months in 2 years. So I'm going to raise it to the power of 4. So it's going to be 4 times 2. 2 times 4 to the 4th power. Okay. Now, substitute the values in. We did that right here. And when we follow the order of operations to solve the equation, we get that y equals 512. So what that means is that there will be 512 mice after 2 years. Example 2. In sporting tournaments, teams are eliminated after they lose. The number of teams in the tournament then decreases by half with each round. If there are 16 teams left after 3 rounds, how many teams started out in the tournament? So first we need to put our known values. Our known values is that each round decreases by 1/2. There are 16 teams left, and the time is 3 rounds. My unknown is the initial value, the initial number of teams. Now, I'm going to use my equation, y equals a times b to the x power. Now, my y value, which is representing my amount that I have left, is 16. My initial value is what I don't know, so I'm going to leave that as the letter A. My b value is the amount that it's changing by, and it's changing by 1/2 raised to and the time period is 3 rounds, so it's raised to the 3rd power. Now we have to go and solve to figure out what A equals. 1/2 time to the 3rd power equals 1/8, so I get 16 equals A times 1/8, and then I multiply both sides by 8 to get rid of that, and I get that 128 equals A, which was our initial value. So 128 teams started in the tournament. Question number 3. The population of a small town is increasing at a rate of 4% per year. If there are currently about 6,000 residents, about how many residents will there be in 5 years at this rate? My known factors is that it's increasing uh, 4%. The initial value is 6,000. The time is 5 years. And my unknown is how many families there will be in 5 years. So I'm going to use that same equation, y equals a times b to the x power. Now, y is going to represent our answer, or how many families there will be in 5 years. My initial, which is representing my a value, is going to be 6,000 times the amount it's changing by is it's increasing at 4%. So remember, I have to make it 1.04 to represent that change. And then it's changing over 5 years. So that's going to be my rate at which it changes. So when I solve that, I'm going to get that y equals 7,300 residents. Last example question, number 4. We want to reduce the size of a picture to place in a small frame. You aren't sure what size to choose on the photocopier, so you decide to reduce the picture by 15% each time you scan it until you get it to the size that you want. If the picture was 10 inches long at the start, how long is it after 3 scans? My known information is that I want to reduce it by 15%. My initial is 10 inches. My time is over 3 scans. My unknown is the length after 3 scans. So I'm going to once again use my same formula, y equals a times b to the x power, and I'm going to plug in the numbers that I know. So y equals, my initial value is 10, times the amount that it's changing, it's decreasing by 15%. So that would be 1 minus 0.15 raised to the power of, it's going over 3 scans, so the third power. Now, when we solve that, we get y equals about 6.14 inches. Okay, you're going to practice on pages 19 through 20 for your first stamps from Unit 7.